Hi everyone, welcome back to CHM421 Analytical Chemistry. This video we will learn a new topic 4, which is titrimetric analysis. As usual, when we start a new topic, I would like to remind you the description of the subject. CHM421 is the course that involves theory and techniques in analytical chemistry. Student will define concept, explain the principle in application, solve qualitative and quantitative problems, and perform investigation via laboratory exercise. The outcome should be assessed through the paper examination, test and quizzes, laboratory skills, and also laboratory report. At the end of the course, students should be able to describe the function of laboratory apparatus, standard laboratory techniques, as well as the principle involved in sampling and preparing laboratory samples. You also should be able to explain the principle in application of volumetric, gravimetric, and basic chromatography analysis to solve the reliability of experimental data. Demonstrate the theory covered by performing experiments in volumetric titration, gravimetric analysis, and chromatography. And also, in the end, student also should be able to report experimental finding in scientific manner. For this topic 4, titrimetric analysis or volumetric analysis is about titration. Okay, this topic will be divided into 4 sub section. The first one is acid-base titration. You will learn about acid-base titration. The second one is complexation titration. Third is precipitation titration. Last but not least is redox titration. Meaning that in this topic 4, titrimetric or volumetric analysis, you will learn 4 parts of titration. Before we go in detail for each type of titration, some basic that you have to understand. The first one is standards. What is standards? When we do the analysis in the laboratory, we will use different types of solution. We can use a standard solution, we can use a stock solution, or we can also have a working solution. So in this slide, you should understand the meaning or the definition of each type of solution. Of course, the solution will be prepared from the starting material. The starting material, we call it a primary standard material or primary standard reagent. So the primary standard material or reagent is highly purified compound that serves as reference material or reagent in all volumetric or titrimetric analysis. So from the primary material, we will use it to prepare the solution. The first solution we will prepare is standard solution. So the standard solution is a reagent solution of accurately known concentration, meaning that when we prepare the solution from the primary standard reagent, for example, from the chemical bottles of hydrochloric acid, for example, hydrochloric acid. So when we prepare a solution from the primary source of reagent or material, we call it standard solution. We can prepare various concentration. For example, we can prepare 10 molar of HCl solution. So this standard solution, the concentration known. So from the standard solution, we can dilute it into a stock solution. So a stock solution is concentrated solution that will be diluted to some lower concentrated for actual use. So in another words, we can further dilute the standard solution. We can further dilute the standard solution to form lower concentration of stock solution for the actual use. For example, we dilute it into 1 molar of hydrochloric solution. So from 10 molar to 1 molar, which have to carry out the dilution. So that is the stock solution. From the stock solution also, we can prepare another type of solution. We call it working solution. So what is a working solution? Working solution is a chemical solution made up for actual use in the lab. So normally the working solution can be prepared from the by diluting the stick solution or diluting the standard solution. Meaning that from the stock solution, we can prepare the working solution. For example, it much lower concentration, 0.11 molar of hydrochloric solution. When we prepare a lower concentration of solution, so we need the dilution. The working solution also is not only can be prepared from the stock solution, it also can be prepared from the standard solution. Okay, so I hope you can understand what is the meaning of primary standard material reagent, what is the meaning of standard solution, stock solution, as well as working solution. Okay, moving forward to the properties of primary standard material or primary standard chemical. The primary standard chemical, it should be high purity. It's typically 100% or plus minus 100%. The primary standard material also should be high stability, because when we open the bottle, the chemicals inside the bottle have to be high stable during the storage duration. And the primary chemical also, it should not contain water. Okay, and it should be a high equivalent weight, because high equivalent weight normally is more stable. So we can have a selection of primary standard material or primary standard chemical. For example, if we want to have a primary standard chemical of hydrochloric acid. So hydrochloric acid can be obtained from different company. So different company will be carry different brand. We can have a brand A. We can have a brand B, or we can have brand C. Every brand, every company, chemical supplier, it supply different percent purity. So from the different percent of purity, the cost will be varies as well. So if you want to use primary standard material or chemical, we prefer the chemical which is cheaper and expensive. And also the chemical, it should be easily available, and it can be soluble. Okay, soluble in mini solvent, for example, can be soluble in water, or can be soluble in organic solvent. Okay, so this is the properties of primary chemical or primary standard material. High purity, should be highly stable, not contain water, and also equivalent weight. High equivalent weight. Okay, how do we prepare the standard solution? Remember, from the primary standard material, you can use it to prepare the standard solution. How do we prepare the standard solution? It's a very simple. A standard solution can be prepared by dissolving accurately with amount of primary standard reagent. So we dissolve the accurate amount of primary standard reagent from the original bottle. So when we dissolve, normally we dissolve using solvent, and then we diluted it into non-volume of solution using volumetric flask. Because volumetric flask can be come with different volume. It can be 100 milliliter, or it can be 100 to can be 250 milliliter, or it can be even 500 milliliter. So the solution we prepared using the primary standard reagent will give the standard solution. So this schematic diagram is to show you how the process of making standard solution from solid. So the solid from the primary standard reagent will be weighed with certain amount, and put it in the volumetric flask, and then we dissolve it with solvent, in this case water, and then we add on more solvent until calibration mark to prepare the standard solution. It's a very simple. With the amount dissolved using the solvent, and then we top up using the solvent until the calibration marks. Okay. As we know, the standard solution also can be prepared from the liquid. The primary standard chemical in the liquid form, we pipe it in the particular volume into the volumetric flask that containing already minimal amount of solvent, and then we add on more solvent until it reach the calibration curve to prepare the standard solution. All right. When we do preparation of standard solution, stock solution, or working solution, we should know the basic calculation or the basic formula. So the calculation for preparation of the solution is just using a very simple formula. It just use formula of mole. Mole is mass over molar mass. Make sure you know the unit, gram per mole. And the second formula is molarity, capital M, is the mole per volume of the solution. So the unit is mole per liter. So you will use this unit, this simple formula, and also this simple formula to calculate the amount of solid or amount of liquid required to prepare a certain molarity or certain volume of solution, regardless of stock solution or standard solution or working solution. We will use these two basic formula. Okay, let's try a simple example. What is the mass of K2CR4 is needed to prepare exactly 0.25 liter of 0.25 molarity K2CR4 solution in water. So the question is asking you what is the mass of K2CR4. So the solution that we prepared in this case is case K2 K2CrO4. So what is the concentration of this solution? 0.25 molar with 0.2500 liter, the volume. So we can know, we have to calculate what is the mass of K2CrO4 that we in to prepare this solution. So by using the formula that I mentioned just now, you can calculate the mass of K2CrO4. Okay, you are given molarity. So you know molarity, I write it here. Molarity is mole per liter. So you can calculate the mole of K2CrO4 in the prepared solution. So in order to calculate the mole, the molarity is 0.250 mole per liter, because the unit of molarity is mole per liter times, why times? Because this one should be times, because we want to know what is the mole, times the volume of solution. In this case, 0.2500 liter. So you can cancel off the unit, liter can cancel off with liter, and then you can use your calculator to do the calculation. 0.25 times 0.25. So is okay, I can write it here. 0.0625 mole. Okay, you know the number of mole for K2CrO4 in the prepared solution. From the mole number, you can calculate the mass because we know mole is mass over molar mass. So in order to calculate the mass, the mole 0.0625 mole should be times with molecular mass of K2CrO4. So K2CrO4, you can use your periodic table. So I just use is given in the answer 194. So it's 194 gram mole minus 1. So you can cancel the unit mole with the mole. So you use your calculator. 0.0625 times 1. 0.0625 times 194. So the answer 12.1 gram. 12.1 gram. So it's a very simple calculation. See the answer similar. So you just use a simple formula, molarity, and also the mole number. But the most important one is you have to understand the equation, what the equation want. Okay. All right. We moving to dilution because if you still remember, I said we can prepare the stock solution or the working solution from the standard solution by using dilution. So what is dilution? Dilution is whenever you add solvent to a solution. So adding solvent will resulting the solution with lower concentration. Okay, so this is the simple formula involved in dilution. M1V1 and equal to N2V2. I think you know this chemical formula, this formula already. M is molarity, volume is the volume of the solution, 1 and 2 is the concentrated and diluted value. Okay, so this schematic diagram is showing you the procedure of dilution. So from the standard solution, we pipette a certain amount of solution and then we transfer it into the volumetric flask, and then we shake it, and then we add on solvent, most of the cases using distilled water, and then we add on the solvent until reach the calibration mark. Okay, remember eye level, it should be on the meniscus. Okay, so this is an example related to the dilution. We can try. It's a very simple. How many milliliter? How many milliliter of 0.5 molar sodium hydroxide? It's asking you how many ml. I needed to prepare 300 ml and 1.2 molar sodium hydroxide. So this is involved dilution. So you're asking what is V1? You know the M1, you know the V2, and also you know the M2. So by using the formula, M1 V1, M2 V2, You want to know what is the V2. If you want to know what is the V1, so M2 is 1.2 molarity, mole per liter, times volume, 300 ml, or you can convert it into 0.3 liter if you want, and then divided with V, sorry, you divided with M1, M1 0.5 molar, molarity. So molarity can be cancelled off. So use your calculator. 1.2 times 300 divided 0.5. So you obtain 720 ml. Okay, this is the volume. If you want to use the liter, I think it's the same, 1.2 times 0.3, 1.2 times 0.3 divided 0.5. Also give you uh, 0.72 liter or 720 milliliter. Oh, okay. Why the answers is not similar? 65, 720 ml. Oh, all right. It write it wrongly. It's not 5.5. It's a 0.5. So this answers is wrong. It should be 0.5. So this one it should be 0.5. So that one should be 0.72, and that one should be 720. So you can write the statement before in order to prepare the 1.2 molar sodium hydroxide solution. So you can add on this statement. In order to prepare of 1.2 molar of 300 ml sodium hydroxide solution, we have to use 720 ml of 0.5 molar sodium hydroxide into the container, and then we add 300 ml of 300 ml of distilled water to dissolve the solution. All right. So it's a very simple. You just use the formula M1, V1, and also M2, V2. Okay. Moving to standardization. So you have to a bit focus. What is the purpose of standardization? Standardization is a process to determine the concentration of solution. Okay, again, to determine the concentration of solution. By what? By titration. Okay, what we want to do the titration? Titrating the standard, titrating with standard solution or solution of known concentration. Again, standardization, we want to determine the concentration of solution by titrating with a standard solution or with a solution of known concentration. So you should understand what is the meaning of standardization. Determine the concentration by titrating what? Titrating with standard solution or solution with known concentration. Because I repeat it many times, so hopefully you can remember what is the meaning of standardization. So standardization can be used for titration. So before for forming the titration, we will do this standardization. Okay. So titration is a procedure of carefully controlled addition of reagent. The addition of reagent, we call it titrant, to the analyte. Analyte is the sample that you want to know the concentration. So which one that we have for standardization? So this region, the titrant, it should be standard should be standardized first. So meaning that we should know what is the concentration of the titrant. Okay, as you can see from the diagram, the titrant should be in the burette. So we should know the concentration. How do we know the concentration? We perform the standardization, because the standardization is to determine the concentration of solution by titrating the standard solution with standard solution or with non concentration of solution. Okay, so the standardized solution should be only in the burette. So because we know the concentration, so the analyte normally we put it in the conical flask. We put it indicator. The analyte, we don't know what is the concentration. This is why we perform the titration in order to determine the concentration of the analyte in the sample. Okay. All right. So this is the example of standardization before we move further to titration. For example, you can accurately weigh 1.325 gram of sodium carbonate in dissolved in water. And then when we add on the water until the calibration mark 250 volumetric flask, we can calculate the concentration of sodium carbonate. Because we know what is the mass, we can calculate the mole. When we know the mass, we can calculate the mole. And then we know the volume of the solution that we prepare, so we can know what is the molar purity, is a mole per liter. So this solution we use it for standardize the hydrochloric acid. So the hydrochloric acid is the chemical inside the burette. So the chemical inside the burette, it should be standardized. For example, if we want to use hydrochloric acid, the hydrochloric acid should be standardized using suitable or a known concentration of solution or standard solution. In this case, we using sodium carbonate. Remember, the solution in the burette, for example, in this case is hydrochloric acid, should be standardized. Okay, how to standardize? We have to determine the concentration by titrating using the standard solution or solution with non-concentration. In this case, you will using non-concentration of sodium carbonate. I want you really understand what is the relationship between standardization and titration. So after we standardize the hydrochloric acid, this will give you accurate determination of the concentration of hydrochloric solution. This is how the hydrochloric solution has been standardized by using the non-concentration of sodium carbonate. and can be used accurately to determine the concentration of base solution. So HCl, standardized HCl in burette, the base solution in the conical flask. The base solution we add with indicator. So this is the chemical formula for the standardization. In this case, we want to standardize the hydrochloric acid with sodium carbonate. Okay. All right. Okay. For a successful trimetric procedure or successful volumetric procedure, or in another way, a successful titration, so the reaction between the chemical inside the burette when analyzed inside the conical flask should be reaction should be stoichiometric. It will define reaction between the titrant and the analyte. Titrant is chemical inside the burette, analyte is chemical inside the volumetric, chemical inside the conical flask. So the reaction between the titrant and analyte should be very rapid, and there, if possible, no side reaction, and the reaction can show some indication because we put the indicator, we add on the indicator with the analyte. It should show some indication when we reach the end of reaction. For example, the common one is the color changes, or a sudden increase in the pH, or zero conductivity. But normally in the titration, we observe the color changes. So we know the relationship between the endpoint and also equivalent point. So that's the several tips for successful tritrimetric analysis. All right, I think that's all for this video. On the next video, we will continue specifically on the acid-base titration. All right, thank you. Bye-bye. See you again on the next video.